Okay, so we're going to be talking about our three trigonometric ratios, sine, cosine, and tangent in this unit. And today is the tangent ratio. So we're just going to focus on tangent for right now. So first of all, let's just introduce the idea or the concept of a trigonometric ratio. It is the ratio of the lengths of two sides in a right triangle. So just consider for a moment these two triangles, and I'm going to tell you that they are similar to each other. Based off of their markings, they're right triangles, and angle B is congruent to angle K based off of the markings there. So by AA, we know these two triangles are similar, and we can come up with a proportion, just like we did in Chapter 8. So our proportion would be like AC is to JL as CB is to LK. So we get this proportion. But if we use our means extremes ratio theorem, which means that we can rearrange these terms, as long as when we cross multiply we would get the same outcome, we can actually write this as AC, so that's this side, over BC, and that's the same as JL, this side, over KL. So if you notice, AC and BC are the two legs of this right triangle, and JL and KL are the two legs of that right triangle. And it looks like because they're equal to each other, that's going to end up being a constant. And then because we're dealing with the two lengths of a right triangle, that's technically what a trigonometric ratio is. So this means that trigonometric ratios are going to be constant for a given angle measurement, whatever an acute angle, B, K, J, A, as long as we're not talking about the right angle, okay? So what we just did there is deal with the tangent ratio. And the tangent ratio is defined as, well, okay, so first of all, when you take the tangent of an angle, it's the angle, the acute angle that you're looking at in the right triangle. And based off of that angle, you're going to look at the opposite leg, okay, and the other adjacent leg, the one that's kind of next to it or helps make up that angle. So this is the adjacent leg. And you write those two side lengths as a ratio. So it's the opposite leg over the adjacent leg, or opposite over adjacent. That's tangent. So if you can just remember that, tangent is opposite over adjacent. You'll be good. Okay, so here's an example. We don't actually need to know what the angle measure is for angle A, but we do need to know the three sides of our right triangle, or at least two of them, because we could find the third one by Pythagorean theorem, right? So the tangent of angle A, here's angle A, is going to be the opposite side, or opposite leg, which is 32, over the adjacent leg, which is 24. So we would say the tangent of A, whatever that angle is equal to 32 over 24. And then you're going to find this as a decimal, and we're always going to round to 4 decimal places. Okay, now, here's the thing. We're going to want to be able to look these things up. We want to know exactly what the tangent of, say, 26 degrees is. And I could use an old-fashioned table like this and say, okay, here's tangent column, and here's the 26 degrees, and it looks like the tangent of 26 degrees is 0.4877. Okay, that's really archaic because this is what they did and this is what they used before they had calculators and technology. But we have a scientific calculator, and on your scientific calculator, if you can kind of see here, there's the sine, the cosine, and the tangent buttons. Okay, so if you're at school, you're going to use one of my yellow scientific calculators. If you're at home, you have your own scientific calculator, or if you don't actually have a calculator, your smartphone, the calculator app in it, if you turn the calculator, you turn your phone sideways, it becomes a scientific calculator, and then it has the sine, cosine, tangent buttons on it. So everybody should have access to a scientific calculator, and this is how we're going to be calculating these things. If you don't have a calculator for whatever reason, there is this table that I have behind this photo here in your textbook, in your gray textbook. It's there. I have some paper copies if you don't have the book with you. Yeah, so let's get started. So it says find the value of x, round your answer to the nearest tenth. So now we don't have letters to designate angle A, B, or C, but they did tell us this angle is 32 degrees. That's the acute angle we're going to work with. So since we know this angle, we're going to take the tangent of that angle, and it'll equal the opposite leg, which is 11, over the adjacent leg, which is x. So this is the equation that we're going to come up with. Now this is where we're going to do some fancy algebra before we do some calculations, okay? This will make your life a lot easier. I'm going to take this x and I'm going to cross multiply and move it up here to get multiplied to the tangent of 32. Then I'm going to isolate x, because that's what I'm solving for, by dividing both sides by the tangent of 32. So I get this fraction, 11 over the tangent of 32. Now on your scientific calculator, there's a fraction key, and it says n over d. And if you click on that key, it opens up a fraction. On the top, you can type in 11, and then scroll to the bottom and type tangent 32. And if you hit enter, it should give you 17.603 ... keeps going. And because they asked us to round to the nearest tenth, this is what we would get. So if you don't have one of my yellow scientific calculators, you have your own, you're going to have to figure out how to navigate your trig buttons. So test it out, okay, knowing that the answer to this problem should be 17.603 ... whatever, and figure out how to use your calculator. And if you have questions, come in and ask, okay? Next one. We can actually calculate the sine, cosine, and tangent for angles using the 30, 60, 90 triangle without a table or without a calculator. And that's because we actually know the relationship in a 30, 60, 90 triangle for the three sides. It's x, 2x, and x root 3. But because all 30, 60, 90 triangles are similar, we can decide what we want x to be. So why don't we let x be 1? So I'm going to say this is 1. Hypotenuse is 2 times 1, so that's 2. And the long leg opposite 60 is going to be the square root of 3. So now if I wanted to know what the tangent of 60 degrees is, the tangent is opposite leg over adjacent leg. So root 3 over 1. And I could do this for the 30-degree angle, right? So tangent of 30 would be 1 over root 3. Of course, I'd have to rationalize. And then if I wanted to do the same thing for the 45, 45, 90 triangle, I could do 1, 1, square root 2 and figure out tangent that way. Okay, last thing, angle of elevation. So the angle, as you're looking up at something, is called the angle of elevation. And you kind of have this line of sight that you're looking up at an object, and then you have a horizontal line from the starting point of where you're starting to look up at the object. And those two lines make up your angle of elevation. So here's an example. Say I was standing on the ground over here looking up at the flagpole. So this line right here is my line of sight. All right? And then this right here is the horizontal. So the angle of elevation, when it says find the height of the flagpole with the angle of elevation is 58 degrees, this right here is my angle of elevation, and that is what is 58 degrees. And then it says you are standing 9 feet away from the base. So here's the base of the flagpole. I am standing over here 9 feet away. I'm looking for the height. So now that I've plugged everything in, I can see that the height is the opposite leg for this angle, and the 9 is the adjacent leg. So that means I'm going to be using the tangent function, or tangent ratio. So I can set up my equation that says the tangent of 58 is equal to the height over 9. Now cross multiply. This 9 gets multiplied in front of the tangent of 58. It does not get multiplied to the 58. Okay, so you can type this in, 9 times tangent 58, hit enter, and you should get 14.403 ... whatever. And we're going to round to the nearest foot, no, 10th foot. Yeah. So 14.4 feet. Okay, so that's it. Good luck, guys. Hopefully that wasn't terribly confusing. Next time we'll talk about sine and cosine.